All right, we're going to have our next sit-down conversation. Jean-Philippe Mai, who is President and CEO of Dundee Technologies, which is doing, speaking of innovation, Mark just talked about innovation. Jean-Philippe and his team are doing very innovative stuff on the processing side, which ties into a lot of the issues we've been talking about today. He's going to sit down with our podcast host, Adrian Pocobelli. Adrian, why don't you take the stage and introduce Jean-Philippe, and we will go from there. Thank you, gentlemen.
So I'm very pleased to present Jean-Philippe Mai, President and CEO of Dundee Sustainable Technologies. And Jean-Philippe, welcome.
Well, thank you very much for having me. I'm happy to be here. Unfortunately, I have to follow Mark, so it's always a difficult act to follow.
Indeed. So great to have you. So, of course, Dundee Sustainable Technologies, we've been seeing them in the industry for years now. For those that are unfamiliar, though, what is the mission of Dundee Sustainable Technologies, and could you give us a little bit of background on the company?
Yeah, no, of course. We're a bit of the odd company in this symposium because we are and have been focused really on the development and now commercialization of novel metallurgical processes for the mining industry, and we actually have been doing so for nearly 15 years now. So maybe not a lot of people know a bit of our history about Dundee Sustainable Technologies. We're based in Quebec, Canada, on the eastern part of Canada, and our technical facility is located in Thetford Mines, Quebec. So we're about 2 hours from Montreal. And Thetford Mines is actually known for its asbestos mining. So we've been mining asbestos in Thetford Mines for over 100 years. And when you first drive to Thetford Mines, you have to notice that there's 400 million tons of asbestos tailings. So they're very difficult to hide. And this is really what brought us to Thetford Mines initially, because as part of those asbestos tailings, there's a lot of metals. There's some magnesium. There's also some nickel content. There's about 0.25% nickel in those tails. So going back to 2006, this is where we first settled in Thetford Mines, where the objective was to focus on the recovery of the nickel from the asbestos tailings. And so back then, nickel was about, I think, $22 a pound. And our approach to extracting this nickel was using a chlorination approach, because the nickel in these tailings are quite difficult. It's not an oxide, you can't leach it. It's not a sulfide, you can't float it. So we've developed a chlorination approach to recover the tailings to recover the nickels from the tailings. But a few years after, nickel price dropped drastically from 06 to 09 to about $4 a pound. So we shifted our focus towards applying, again, a chlorination approach for the recovery of precious metals, notably gold. So this is really what was the birth of our Clever process. So again, we use a chlorination approach to recover and to solubilize the gold. And so it took a few years for us we built a pilot in 2008, operated it all the way to 2011. And then afterwards, we moved also to the creation of our industrial demonstration plant. So in 2015, and through the support of Dundee and various also grants that we've received from the provincial government and federal government, we're able to build our industrial demo plant. It has a nominal capacity to treat about 5,000 tons per year of concentrate. So quite significant, allowed us to generate a lot of data and demonstrate the applicability of the process. And of course, when you're developing a new gold process in the mining industry, we've worked and treated a lot of different material, and people send you their worst material. So we've treated a lot of refractory and complex material where very often that that refractory component, that complexity comes with the encapsulation of the gold within a sulfide structure, notably an arsenopyrite structure. So when we were decomposing that arsenopyrite structure, we were left with an arsenic product which needed to be stabilized. And this is what drove us to develop our second process, which is our glass lock process, which is a permanent way of stabilizing arsenic using vitrification. So as we're developing our gold process, we had just finished building our industrial demo in Thetford Mines. Then glass lock was gaining a lot of momentum due to the demand to handle arsenic. So we built our first pilot plant in Thetford Mines again in 2016, operating about a ton a day scale for the vitrification of the arsenic. But then that rapidly materialized to the building of our industrial demo plant for glass lock in 2018, and this one was on-site an operating copper smelter in Namibia. Again, specifically for the stabilization of arsenic coming in the form of trioxide. So we built the pilot for glass lock in 2018, operated it in 2019, and then handed it over. And since then, we've been working on a lot of different projects and developing the data for subsequent on-site operation. And again, with the applicability of Clever, in 2024, we've ran some electronic waste material through our plant because the chemistry of the process really applies to different type of ores, including the electronic waste. We're still mainly focused on the mineral aspects, but that was another interesting stream for the application of Clever.
No, very interesting. As I hear you speak, I just think of how early you were to this. I mean, we're seeing now all sorts of companies pop up, especially in the United States, for treating tailings and so-called waste. So it's quite interesting. And so, in a sense, as you look off in 2025, in a sense, what's driving your strategy right now? Is it technology? Is it the supply chain? Is it environmental? Maybe it's all of the above. How are you seeing your strategy in that regard?
Well, a bit of all of the above. We're quite responsive also to the interests that we are receiving. If we can talk about some of the trends maybe that we've been seeing in a recent past, of course, with gold price being quite high at this stage, there's a lot of new gold projects that we are approached. Especially tailings project, but you mentioned tailings, but we do work with tailings, but we're not a tailings process per se, where we can work with ore, with concentrates, but now with the gold price, there's a lot of people coming to us with tailings that are rather low in concentration, but with the hopes of obviously turning this to a viable project. I think there's definitely quite a good momentum for the gold. And arsenic has been a main and a very important driver because there are more and more, as the oxide deposits are depleting, we're going deeper, getting more to the sulfide, where they are very often associated with arsenic-bearing sulfide. And you can see this on the precious metal phase and also in the base metal. So there's been an increasing amount of work that we've been doing specifically on high arsenic precious metal concentrate, but also on a high arsenic base metal concentrate associated to copper concentrates. And there's also a bit of a trend to look at new technologies and new approaches. As you said, we've been around for quite some time, but when you're looking at the processing of complex material, you have processes like BIOX or like pressure oxidations, which some people have tried, but it doesn't work on all cases. It's not always applicable. There's some high capital costs associated to them as well. And especially when you're treating those very high arsenic concentrates, you don't always have enough iron to arsenic ratio to generate a stable ferric arsenate. So more and more there's interest to look outside of what is known as traditional technologies to treating some of these complex ores.
Okay, excellent. And so how do you, could you go a little bit further into how these actually work then? Say like the clever gold extraction process, the glass lock, arsenic vitrification. Are these solutions? How does this work without getting too technical?
Yeah, no, I definitely don't want to bore anyone with chemistry, but I think it's important to know that we're very open as to how our process works. We're not a black box. We really believe that adoption goes through understanding. And for our gold process, I refer to it, we use a chlorination approach. So we use sodium hypochlorite with a catalytic amount of sodium hypobromite. So essentially, it's household bleach, just like we all have at home, but in a dilute concentration. So we use about 2 to 4% concentration of sodium hypochlorite in acidic pH to rapidly put the gold into solution. So we know that chloride is good at fixing the gold, but bromide is even faster. So we're utilizing bromide as a catalyst to very rapidly solubilize the gold. And then we regenerate our sodium hypochlorite using an electrolysis cell, a membraneless electrolysis cells, which allows us to be very, not astringent in terms of brine control. So the process, yeah, it works very well. And as for a glass lock process, arsenic is known to volatilize at very low temperature. That's why pyrometallurgical processes have not been often used for the handling or the stabilization of arsenic, although vitrification has been used in the past. But the novelty that we bring is we are able to form an intermediate compound, which is stable at the melting temperature of glass. So that allows us to incorporate high amounts of arsenic within a glass structure. And really the objective and the quality of the glass is that it's an amorphous product. So there's no crystalline phase. So there's no crystalline form to affect, which would then remobilize arsenic. So once we generate that XRD diagram and we know we have an amorphous product, this leads us to an understanding that the glass is a stable product and will respond well over time. And with the ability to handle arsenic in the form of arsenic trioxide, we've really worked a lot and developed a way of removing arsenic from these sulfide concentrates. And we do this using a pyrolysis, which is essentially an inert thermal decomposition, which allows us to remove the arsenic, stabilize it, and to generate an arsenic-depleted metal concentrate, which can carry on to market or to smelters, but without the inferred penalties associated with the high arsenic content. So that has been a major driver in our business. And I think it's important to know that our processes, there's no specific or new piece of equipment that we use. If you walk in our plant, there's nothing that you will see that you've not seen before. So we're utilizing equipment that is already being used in the industry. Sometimes we use it for different or off-spec or different purposes, but we've tried to keep things very simple. Again, for efficiency and to de-risk anything going forward, right?
That's fascinating. And so what kind of companies have been using this? Is this from the small to the large? What kind of mining companies are using this technology?
We've seen the full spectrum. So we work as much with early stage junior developers, which have a property that they come to us with the first samples where we do their first met test, and we work with them on developing a flow sheet where in this case they're looking at really starting off and setting their own priorities at looking at an efficient or an alternative process that, say, does not use cyanide or already provides an answer for arsenic associated with the material. All the way to the majors where we've worked on multiple projects in-house where we're applying our processes and developing the engineering and the costing behind the application of the process. And It's funny because sometimes it comes from the C-suite down, or sometimes it comes from the technical group that, and sometimes they collide, and it's not always easy with some of the majors to move forward. But no, we work with companies on all spectrum of the industry.
Okay, very interesting. And of course, we've been seeing the reshoring of the supply chain in recent years. It's top of mind for many, policymakers, as we've discussed here. Are you seeing kind of a renewed interest or extra interest in what you're doing as a result of this, particularly with this concern and interest in green metal, so to speak?
I think yes. I think the interest has always been there. I think we definitely, the industry really knows also what it needs to do to have a viable and an efficient project in terms of processing. And we are, I believe, providing a tool. We are an option where we're providing processes that can be applied and can be used to meet certain environmental criteria, whether we've had talks on green metals here in the symposium, whether there could be some sort of premium to it, or that, I don't know about that, right? But I think that there are a lot of companies like us, and I think we're one of them, offering an option, offering a tool to meet some of the KPIs for the project, where I think our objective is always to offer an efficient approach, right? Where we look at reducing plant size for similar throughput. We look at eliminating liquid effluents by having effluents which can be efficiently recycled, by generating solid tailings. I think that's an important one, where a lot of people are coming to us needing to have this flow sheet where they have a solid tails, and the nature of those tailings, right? Where I think some of those challenges that we've seen are not always technical. I think there's a technical solution for a lot of these challenges, such as sulfide removal. Well, we think that sulfide removal is important. It's important for our process. It provides efficiency, but it provides the ability to generate clean and inert tailings. In our case, in Thetford Mines, there was a case where we were able to repurpose our tailings, mix them with municipal sludge, and then use them for revegetation purposes. So again, we just want to be a tool for the industry to meet its own KPI, right?
Okay, excellent. And oftentimes we'll see in the headlines, arsenic and cyanide tend to get a lot of attention just by the nature of the contaminant and the word. Are you seeing, and the reputation, so to speak, of these contaminants, are you seeing a particular interest in certain contaminants that are to be removed, or anything in that regard?
Well, as I mentioned, I think arsenic is definitely been a growing challenge in our industry, whether and it differs depending on either the jurisdiction or the project. We've been working a lot lately on the South American larger copper porphyry deposits, where you have an increasing amount of energite or tennantite present in those concentrates, where it's important to from the business model to look at either removing or neutralizing the financial impact associated with the arsenic, whether it's sending it through market and the penalties associated with it, or handling it on site. So definitely arsenic has been a key driver. So whether we work on removing the arsenic from the concentrate or we follow it at the smelter, we work a lot with some of the smelters where they're seeing an increasing amount of arsenic in the ores that they're treating. So arsenic is one of those things that whether you have a little bit or you have a lot, you seem to have a big problem. So being able to address and to work with arsenic in its different form, whether it's as a legacy waste in the form of trioxide, or whether it's within the sulfide concentrate, or whether it's in solution coming from various smelter effluents, arsenic has definitely been a key driver. And in terms of gold, also, we're seeing some jurisdiction that they're asking for the projects to go all the way to doré, so wanting to keep the doré in the country. And in some cases, it's easier said than done. So you need to have some processes that can allow you to do this in an efficient manner. Right?
Okay, excellent. And so as we wrap up here with a minute left, Jean-Philippe, how can you turn environmental compliance into an advantage for yourself as a mining company? How should mining companies look at this?
Well, I think we've always seen ourselves as wanting to offer an efficient tool for the industry. And I think efficiency is definitely driven or wanting to be positive in terms of a cost standpoint. So, and it comes down to decision. There's a cost of not doing something. There's a cost of not dealing with your arsenic, right? We have a great example in Canada with the Giant Mine. There's, I believe the latest budget was $4 billion to remediate 237,000 tons of arsenic trioxide. So it comes down to choices. There are costs to not handling your sulfur, not handling your arsenic. But again, we prone efficiency, and I think that in a lot of the projects where we work, we're able to show that there's definitely some value and some benefits to utilizing technologies such as yours to really benefit the project.
Excellent. Jean-Philippe Mai, President and CEO of Dundee Sustainable Technologies. Thank you for joining us.
Thank you, Andrew. Thank you. Thank you very much.
Great job.
Thank you.